the webinar, A Better Way to Approach Strategic Mine Planning, sponsored by CIM Magazine and Dassault Systems Geovia. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine, and my co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Just a little housekeeping before we get started. To ensure you have optimal audio, if you joined by computer, if you joined by computer, please make sure you've selected the computer button. If you joined by phone, please make sure you've selected the phone button. And if you have any questions during the presentation, type them into the question box in your GoToWebinar control panel. It's underneath the question mark. Now I will, the questions will be held until the Q&A period after the presentation. Now I will turn the presentation over to Ryan to introduce today's presenters. Thank you.
Great. Thank you very much, Michelle, and thank you everyone for joining us today. Today's presenter is Hamish Sinclair Ross. He's a R&D Apps Portfolio Senior Manager at Geovia. Experienced in both operational and technical mine environments, Hamish is skilled in Vulcan and XPAC, project and contract management, and mine ventilation, holding statutory ventilation officer tickets for New South Wales and Queensland. Known for his clear communication, adaptability, and practical problem solving, he delivers robust and effective mining solutions. Now, given that Hamish is in Australia, we have pre-recorded his presentation so that it is more convenient for those of us in North America. And then we have Shoei Jrej, who is a Geovia Industry Process Senior, who will join us for the question period to answer any questions you may have about the presentation. So with that, let's begin the presentation. Thank you.
Hi, my name's Hamish Sinclair Ross. I'm the Apps Portfolio Senior Manager responsible for tactical mine planning, and I work in the Geovia R&D team. So just a little bit about myself. I'm a mining engineer by profession, and I've worked at a range of mines, predominantly in a technical services team, working on mine scheduling and mine design. And I've got a real passion for developing tools that assist mine planners and mine designers to be able to create robust and practical mine schedules. So what I've loved about my role here at Geovia is being able to have a direct impact on the tools that we use to do those sorts of things. So what I'll be doing today is taking you through the use of MineShed to be able to rapidly evaluate a number of different scenarios, in particular things like mining direction and the impact that would have, and then be able to focus on some new functionality that we've recently developed, and that's the ability to be able to estimate the amount of process waste which is needing to be handled in tailings dam. So given the mining disasters in recent history associated with tailings dam capacities and the amount of processing waste is a really important topic, and it's something that I've really worked on to be able to bring that into MineShed in the recent years. So to start this presentation, I want to first talk about one of the key challenges that mine planners have, and that's the ability to rapidly generate mine schedules to explore a range of options. Now, in my time working at mine sites, that annual budget, the 12-month preparation is intensive and time-consuming, and the time required to set up and test a range of different scenarios and check all the assumptions, the key assumptions that you wish to use. That setup time often takes more time than actually exploring the key outcomes you're trying to drive. So in MineShed today, and just in a very simple data set, I'm just going to show how easy it is to be able to change some key metrics, explore the results, and to be able to move towards a better outcome before you start narrowing down to some of those finer details in your short-term and 12-week schedules. So MineShed at its core is a block scheduler. So it works best with directly referencing a block model. And in particular, it's recommended here that an engineering model is prepared with a block height in particular that matches things like your bench heights if you're working on a surface mine. Some of the key things we want with our block model is to have a material class attribute set up which captures what each block represents in terms of material. So we've got a very simple example here with some waste, some low-grade ore and high-grade ore. Along with that is we want to be able to track what our qualities are. So whatever the commodities are we're looking at, lead, zinc, copper, gold, depending on our resource. And so this covers many different commodity types. One of the things I love about Mindshed is it's how auditable it is. So at each key stage, we can generate these reports to validate what we're working on. So here you can in effect be able to check what your overall geological model looks like. So if you've got a few different models you're working with, this is a great way here to be able to ensure that you're working with the right numbers and you're not having any surprises in terms of the results. So it's a check step, and Mindshed has a number of check steps to make sure you're working with the right data. If a change is made to the model, say an update to the block model has been implemented as part of an annual review, we can see a flag will appear, and we've got a refresh tool to be able to completely refresh the data we're working on throughout the whole of the schedule to make sure that we understand when a change is made to our source and we can act on it. From here, it's a simple process to be able to map out the material movements. So set up our locations, set up the mining methods, our constraints, so working with our design, and so it's very flexible in terms of it's constraining a block model by a topographic surface in a mine design, or we've got a constraint which selects the blocks within that particular criteria. It's very flexible in how you wish to constrain the blocks and then break down the schedule into what it is you're looking to do. So in this example here, we're looking at more of a medium to long-term schedule. So by selecting a benches mining method here, we can define where a reference bench position is, whether it's top, bottom, or middle, the first bench elevation, the final bench elevation, and bench height. And importantly here, we can set a direction. So this could be north, we could use by azimuth, and there's a range of different ways we could set a mining direction. And by consolidating the blocks here, we can if we've got lots of small blocks, we can consolidate those into a size, which is going to speed up the schedule. So it's going to be really flexible when it comes to the block models you're working with, and to be able to ensure you're not going to have a really lengthy schedule time due to the size of the blocks. Once we've got our model set up, we can go through another check stage. So now we can start to see the tons, grades and volumes associated with each bench. So again, this enables us to check what we're working with for each of their locations. And so this schedule can be as simple or as complex as you wish it to be. So in terms of parameters here, we can apply swell factors. We can apply the maximum number of benches we wish to be working on at any one time, and the lag distance between benches. It's all very practical and all things that can be quickly set up to be able to get a result. Once the schedule's been run, it's possible to be able to view the results of the schedule in a really interactive animation, as well as generate reports and graphs which help us to better understand the results of the schedule that we've just created. So really important validation tools that are simple to set up and powerful ways to be able to both validate the schedule and share the results with all the key stakeholders you're working with. So you can see here we're happy with 3 benches that are working at any one time and the standoff distance between benches. Now if I check our processing plant, we can see that in most cases here we can achieve the desired throughput rate. However, our grades are pretty erratic. We can see here on the second here where we've got a lot of variation. So one thing we could do is go back and see what difference changing the mining direction makes. So this is one of the real strengths of Mindshed. It is so simple to make really critical changes, rerun the schedule, and check the results. There's very little extra setup required, and we can see what the results are of our schedule without too much drama. So we've still got the variation, but I think arguably a better result. So we've got no issues with throughput. we're seeing a bit more of a rising throughput grade, which could be desirable. So we can see some value here and being able to changing the mining direction coming on that west pit, coming from a northern direction is going to give us a better result. Now, one of the other benefits of using Mineshed is a couple of opportunities to use an algorithm to help us deliver a better result given the setup. We've got the ability to apply targets, quality targets, which deliver or chase a constant feed grade and a set target, as well as blending ratios if we've got a product stockpile, we wish to achieve an ideal blend. So in this case here, we're going to target a constant feed grade to the plant of 1.1 grams per tonne, and we'll see if that's what that does to our schedule. So we can see the results of this quite clearly. We don't have any issues with throughput, it's consistent, and we've been able to achieve a really constant feed grade to the plant. This is what most people consider the best case. So what it does prove to us is that with this particular operation, at any stage during the mine life here, it is plausible that we could blend the material together to be able to deliver a constant feed grade to the plant. And so obviously the power in this is, if you've got a sensitive plant here, you're going to be able to achieve the best possible recovery because you'll be able to blend material to deliver a constant feed grade, which is at that sweet spot. And that's a really important tool to have in your toolbox when you're looking at mine planning. We might take a step over to the haulage process. So what a lot of people do, first build up their production plan, get a result that they're pretty comfortable with. Now this could be a matter of several different scenarios, a base case, and then making sequential changes until you're quite comfortable with the results. And now we might want to see the impact of the schedule on the haulage design we've got. So Mineshed's got the capabilities here to be able to estimate the number of trucks you would need to be able to support your production plan. So we can bring through our haulage road design for the life of the mine, considering any bench roads, so the path that trucks may want to be. You may want the trucks to travel along a set route through to the main haulage route across each bench. For each truck in our truck library, we can apply our rim pull and retarding tables to be able to estimate the speed at grades based on the road conditions. We can modify the availability utilization of the trucks. And so over time, it's entirely possible here that we could see, well, what does it look like? What the number of trucks we would need if we've got a bit of an aging fleet and we're seeing our availability and utilization of our trucks drop off as the maintenance increases. We can understand that. For each one of our roads, we can group them by road types, and we can change the rolling resistance of that road over a year. And so if we've got a wet season, we can apply a higher rolling resistance for that road during the wet season to model the impact of wet and dry conditions during the year. And we can apply that as a seasonal change. So that'll roll it through every period, every year. It would apply that. And so be able to bring in some really practical abilities here to estimate the road conditions and the impact that has on the trucks that you're using for your haulage planning. And we've been able to automate this, so automatic routes. So setting up a network here without having to physically say for each route, you must go this road, then that road, then that road, then that road to get to the destination. We select the destination for each material movement path and the truck we're wanting to apply to each material movement path, and we're going to be able to assign as a automatic route. So it actually works it out. It works out the shortest distance to reach the destination based on the haulage network. So that's a big time saver. That's allows people to bring the design over the life of mine, and depending on which block has been mined at different stages, it works it out without having to physically set that up yourself, which saves a lot of time, and especially for those complex haulage designs, can be a really big time saver. And so we can, once we've got the haulage set up and we're comfortable with it, we can go back without having to necessarily redo the whole schedule. There's a simple tick box here, which takes a production plan and applies it to the haulage planning tool to get the haulage results. So that means we can now go into checking further options here to check the results of our schedule. So in this particular tool here, we can now check as a way to validate. And there's lots of information here, but we can see for any particular block, we can see the path it's taken. So there's a lot of information here, but then ultimately what this helps us to do is to check that we don't have any weird results with our haulage plan. We can see for each block, it's followed a logical path through the destination, and it's something we're quite comfortable with. Okay, now brand new for Mindshed is the ability to be able to focus on the tailings dam, as well as develop a lot more options around the processing plant and the impact that feed, product and grade has on recovery. So we started our processing plant here. We've now got a lot of new features that have been added to be able to better forecast what things like recovered metal and our processed tailings look like. So a important new option here for about to be released in Mindshed 2026 Refresh 1. So this isn't quite available to everyone just yet, but it will be shortly, is the ability to be able to create process paths. So what this is all about is we could keep this really simple and having a single stage where all the material is crushed and goes through a crushing grinding circuit, passes through the concentration and then onto refining and things like that in a single stage. We could have a single process path. But if we've got a more complex operation that has, say, an oxide and a sulfide material that you wish to treat separately, we can select a group of material types and allocate them to a single process path. So you can have multiple process paths here, and to be able to combine those material types into that process. In this example, I've only got the one, but like I said, if you've got a lot more complexity, we can then cover that. And the importance here of combining material, because once a material goes through a processing plant, it's no longer a separate material type. It becomes, it's crushed and ground up and it goes through the process. It's a single product that's grouped as a process path. So you'll see here, in addition to that, we can apply our recovery factors to the feed grade. So you can have, if you've got multiple products, you can have multiple commodities here that for each process path, if you've got a copper gold, you can estimate there what your recovered metal is going to look like. So the recovery you could expect. You could apply a simple recovery factor as an integer, say between 0 and 1, so it's 0.8 recovery. That would say that all the gold passing through the processing plant here, 80% of it is going to be recovered and 20% is going to be sent out as tailings. What we've also done here is the ability to apply a recovery expression. It's been designed to reflect how you'd set this up in, say, products like Microsoft Excel. So use an if statement here, if and statements and things like that to be able to say what the recovery looks like when you've got variable grades coming through. And for those who've used Mindshed in the past, generally Mindshed is unitless. And so it's up to the mine planner to be able to understand what the units were used in the block model, and that carries through to the reports and things like that. As we start to move more into material balances, units become critical. And so for the first time here, we're going to be able to define for that gold property, what's that gold attribute in the block model measured in? So we've got a range of options here, and we can be able to choose grams per ton. And when we're talking about recovered metal, we don't want to have to then go through and work out what our final conversion rate is into the reporting standard we wish to work with. So we've got a range of options here we can choose. So depending on the commodity, gold here, we're looking at troy ounces. And so it applies that conversion going from tons, so grams per ton, and converts it through to, so tons at the end of gold per period, and it converts it into troy ounces for our reports downstream. And after we've got our recovery factor set up, we can now start thinking about our processing waste. So there's two simple triggers here at the moment. First of all, it's how much of our process waste is going to be reporting to the tailings dam. I've got this set at the moment to 100%. So 100% of our processing waste is going to end up in our tailings dam. And of that tailings, what's the moisture percentage? So of the total, what amount of water do we need to add to turn it into a slurry? So we're looking at 80% moisture factor, the percentage, sorry, of water is going to be, so the added water that goes into it to turn it into a slurry to manage the material that's going to be reporting to the tailings dam. Now, if we set this to something less than 100, say it's 80%, we can set up another stockpile, as we have here, that's going to be our solid process waste. So we can capture both. So if we've got a process here that does have some solid waste we need to manage on the surface, we can also manage that situation as well. So this is also new for Mindshed 2026, is the ability to set up a tailings dam for the first time. So we've got a capacity here. So especially at our starting point, I'm going to set a really high capacity to be able to measure and okay, well, how much tailings capacity are we going to need? I'd always recommend we start with a really high figure so we can work it out, because Mindshed's got a fail safe in it. When you run a schedule, if the tailings dam capacity is reached, the schedule will stop. It'll tell you why it stopped. And obviously in that stage here, you've got to think about, well, what do we do to address that problem? So this is a great way to evaluate how much tailings material you might need to manage. And along with that, we've got a rate of evaporation that we can apply, because with all that water, some of the water is going to evaporate on a daily rate, as well as the ability to remove water, to model there. If we've got a dewatering program on a rate per day, sending water back to the processing plant because it's very water heavy, we can capture that as well. All those things can be modeled in our tailings dam. So if we're comfortable with that setup, and I should also say, this object automatically appears as soon as we apply a recovery factor. We'll have a production stockpile here, which is our repository for our recovered metal. Now, just talking about this assumes a holistic workflow that goes all the way through to refining to get a recovered metal, something we are working on for the Mindshed 2028 release, which will be is still a work in progress. We'll be focused on the ability to be able to report a product concentrate. So rather than at the moment looking at recovered metal, which is great, we also know that many people don't have access to a refinery, and what they actually sell is a product concentrate. And they sell that concentrate on to a company that has a refinery. So to increase our flexibility, that's something we're working on. So it's not there yet, but that will be delivered shortly, is the ability to be able to model the processing plant working as either a concentrator or as a refinery to be able to achieve that recovered metal state. So that's all work that's continuing to be able to increase the understanding of how we manage material from start to finish at a mine. So now we can go and check the results. So some new reports have been added specific for the new workflow. So we've got recovered metal we can check, and processed waste management. So for each period, we're able to understand all the details associated with the processing stage. We can see what our recovery factor is, the number of what we could estimate or forecast in terms of the troy ounces that we've recovered. And understand here if we've got some variation, whether that's an impact, where we can expect an impact on our recovery factor. So because we've got the targets set up, we've got a constant feed grade, and so we're always operating in our desired sweet spot, which is a great outcome for us. So we're always going to, as long as we can achieve that constant feed grade, we're going to deliver the best possible outcome for our gold recovery. For our process waste management, we're tracking what the tonnage and volume of the raw material, or the material that needs to be managed within a tailings dam, as well as the amount of water. Now, the reason why we're tracking water is we're looking at the mass balance, as we can see how much water is added, and then considering the amount of water that's lost to the process for each period. So as we get to the end of the mine life, you can start to see, well, how much water is there remaining, and what's the process there of the material drawn down. And ultimately, getting to the end of the schedule, we can understand what's the mass and volume balance that we need to be able to achieve at the end of the mine life to be able to handle all the operations here. So we can see here just under 19 million tonnes, or roughly 15 million cubic meters of capacity we'd be forecasting. So it allows you to go back and start thinking about a tailings dam design, which is going to be able to handle that, and obviously within stages. So it could be, using these numbers to estimate what your stages need to be for your tailings dam. And going back into our scheduling process here, if we've got a series of stages, we can achieve that. And that's something that can be done. Take a look at the tailings dam, so we can see a date event at a certain stage. We're going to increase the capacity to represent different stages. So there's a lot of flexibility here, and we're going to continue to work on the waste management. And so it's the start of a long journey, but we are committed to being able to forecast and manage waste, given that especially processing waste is such an important part of the mine planning process. We feel that we really need to be able to give mine planners the tools to be able to understand all the aspects of one mine waste management, not just the dump or fill capacities for the solid waste that we need to manage. Now, I'll just finish things up with some of the reporting tools that we've got available to us, and a couple of words around what our focus is for the future. So MineShed's got the ability, once we've got a plan that we're quite comfortable with, it's possible then to be able to export a set number of reports. So if we have a look at the MineShed help, it tells us what each report delivers, but this can be delivered to your results folder, and it's the same every time. So it allows out to be easily generate a set of reports with a single click, which cover a lot of the reporting needs we may have. The same can be achieved for specific to haulage, and we can actually also connect to a MS Access database or via ODBC to any database we wish to be able to push the results of our schedule in different areas through to a database of our choice, as long as we've got an ODBC connection to it. So this enables us to connect into the different databases to help integrate the production planning process into things like maintenance planning and things like that. The same can be done. We can connect to data sources and be able to push things like maintenance plans into MineShed to be able to ensure that we're developing practical mine plans. Now we move across into custom reports. The custom reports is a really flexible way to be able to set up any reports that you wish to be able to be generated repeatedly. It differs from the standard reports in the way that this can be set up to be whatever you wish it to be. So these ones, the standard reports are a select number of reports that over time we felt that deliver value to people without needing to set up anything different. This allows you to set up a reporting standard that can be applied. So every schedule you create, you can, assuming you've got this set up, you can just go and create the reports following the schedule being run, and it outputs it in both a CSV file and an Excel spreadsheet format as well. So in this case here, we've got a bit of a coverage summary of the mass movement across the site and something specific to haulage, just as an example. So with this set up, we can create the reports. And then once they're finished, we can go and view them. And we can see here the results. And there's potential after that to be able to process them and have a template that's set up. So once a template's been set up, you can go and color them. Assuming nothing's changed in here, haven't changed any of the columns, you set up a format, and then each time the schedules run, this template is then used as the source and it gets updated with the latest results. So before I conclude this presentation, I just thought I'd provide a quick overview of the key points that have been raised. Mindshed as its source is a block scheduler. It's something that makes Mindshed fairly unique in the tactical mine planning solutions that are available. It allows us to work on a single source of truth. So if a change has been made to that source, we can quickly refresh that material to push those changes throughout the scenario to make sure we're always working on the single source of truth. Mindshed can be simple or it can be complex. User calculations can be set up based on allow us to use attributes from the block model to further create reporting tools, things like calculating NPV as an example, and user parameters can be used to be able to set up additional parameters to tweak the schedule in different directions as we see fit. Mindshed has an intuitive workflow that steps it through in a logical way, going from the geological model, setting up the mining locations, haulage, our production rates, defining production rates in various ways. We can define something we haven't gone through, and I haven't covered everything in Mindshed because it would just take too long. As we're more focused on the longer term planning workflow, but Mindshed also has a really strong shorter term planning workflow as well that has more of a focus on managing and sequencing mining activities, say for blast locations. We can also set up underground mine schedules, or we can do both. So it's got a lot of flexibility here. So again, it can be very simple, it can be surface related, it can be underground related, it can be often fit for a 12-week schedule, or it's something, as we've demonstrated today, more so something that's more focused on a longer term mine plan. For our mining locations here, the benches mining method allows us to use parameters to set the maximum number of benches we wish to have available at any one time, lead and lag parameters to allow us to set up practical constraints to make sure that we're delivering very quickly a practical result. We also focused heavily on the improvements to the ability to forecast recovered metal, apply a recovery factor in our processing plant, and also to be able to estimate the needs for our tailings dam. That area is a strong focus for us at the moment to make sure that mine planners are empowered to accurately forecast what their tailings management needs are, in addition to what we can already deliver in terms of estimating the amount of the volume and tonnage of waste material that we need to work with. Setting up the schedule is quick and easy. Making changes can be done in a methodical way, and it's clearly auditable, and checking the results can be done simply using some powerful animation tools here. This can be saved and exported as a movie file for others to view as well, and it's an important validation tool and also a way to communicate the plan. Dashboard reports allow us to check our schedule, and we've got ability to export standard reports and set up custom reports that deliver, once we're agreed on a plan, something that, in addition there, we can set up templates to be able to further communicate the plan. Now, finally, I want to mention a few things about what our vision is for Mindshed going forward. So on the current releases we're working on at the moment are very much focused on improving the ability to generate custom reports. These filters are very simple to set up. We can achieve a lot of what we need using these filters. The next steps for us is building up a spreadsheet view for this purpose. So be able to use the filters in the same way, but be able to see the results in a spreadsheet view inside Mindshed to be able to apply all the desired color schemes and all those sorts of things to be able to make it fit for purpose, and to be able to, when we export a report, it's ready to go. It's ready to be shared, and something that can be set up and the same every time. That's one of the key things we're working on to further strengthen our ability to generate forecast accurate production results from our processing plant. We're going to strengthen our processing plant workflow to include concentrate calculation. So you're applying an accurate mass balance equations to work out from a concentration stage what sort of tons and grades of concentrate we could expect from the input to the plant. Many people don't have refineries or direct access to refineries. So while recovered metal is important, many operations are going to be more concerned about concentrates. So that's something we're working on at the present to be able to strengthen that workflow, to be able to set up multiple plants. So a plant that covers concentrate calculations and tracks that, and then to be able to set up a plant as a refinery. For some of our longer term plans, we're also very focused on strengthening our haulage workflow. Given that haulage is such a large cost to an operation, it's really important that we're able to accurately work with not just how many trucks we need to support the production, but the impact of our haulage fleet on our production. And that's the next journey for us. We're going to be working on integrating haulage closely in with our production planning process to be able to set up a haulage fleet and model what the impact of that haulage fleet is on our production plan. The final key topic I want to talk about is the area of compliance to plan. Spatial compliance to plan can be quite a difficult metric to work through, and there's a number of ways that we're focused on addressing that particular problem for mine planners. What our vision for Mindshed is to be well integrated with our strategic planning tools, and one of the key areas is be able to capture at different stages of the mine life on the strategic plan where we need to be spatially, in 12 months and 24 months, etc., what that mining progression looks like on a strategic front. If we can capture that surface, we can compare it to it. So strengthening the end of period shapes that we generate, and then being able to compare that to the strategic plan to be able to quantify what areas did we mine in plan for that stage of the mine life, what areas were mined outside of the plan, and so forth, to be able to quantify that both numerically and also visually, importantly as well. To be able to capture those things is a really, really important metric, and something there to make sure that the tactical mine plan is in lockstep with the strategic plan. And if there is deviations that we're seeing, we can do something about it before deviations in a situation now you've really deviated from the strategic plan and you're seeing a less than ideal outcome from your planning process. So integrated planning is that final key item that we've got in the shorter term focus. Mindshed's got a long road ahead, and it's exciting to see the product grow from strength to strength. So these are the key points I wanted to raise for today's session. The last point I will raise is I really love to hear from operating surface mines, consultants, people who are in the mine planning and design space. I'm keen to hear about what your challenges are on a day-to-day basis, what your experience is if you're a Mindshed user, because my passion for this role is improving the day-to-day life of mine planners and mine designers. So I love the fact that I can influence this product to see better results and to be able to solve different problems for operating mines. So always keen to hear your feedback. Work out what Mindshed is where it is today, where it needs to be, what other problems should we need to be focused on to be able to keep driving the product forward to continue to solve problems. So thank you for your time. I appreciate it. This is being recorded, so I will keep on top of any questions that are raised, and really happy to reach out directly to answer them. So thanks a lot.
All right. Well, thank you very much to Hamish for providing that presentation. So as we mentioned, we have Shoei here to answer questions that may arise, and we do have a couple for you. So Shoei, I just noticed you're on mute at the moment. Okay. So one question we have here is, does the capability exist to model infilling of a tailings pond, considering the deposition of multiple types of tailings products simultaneously, such as solids, slurries, water?
Yeah, It does now in the most recent. It's a very recent upgrade to the software that we've put in just in the past few months. So what we're able to do now is model the input from a processing plant to a tailings dam in terms of the quantity of solids or liquids in a slurry, as well as evaporation. Okay, so yes.
Great. Now, and someone else asks, can you tell them how to calculate and graph stripping ratio?
Okay, yeah, we can. Um, in terms of graphing the stripping ratio, so let me take a step back. Uh, as Hamish mentioned, Mindshed is a block scheduler, a production scheduler. It schedules all the material being produced from whatever mine, open pit or underground or both. Uh, every block, because the source material, the resource model is a block model, it knows which blocks are ore, which blocks are waste, or whatever other materials are defined for the particular deposit. So one of the results it keeps track of is not only tons and grade, but tons and grades of every single material mined. So to either graph or report the stripping ratio, it's simply a matter of graphing or reporting ore against waste. And there's different ways to do it, but it's a rather easy thing to do.
Okay. Most mines don't have access to a refinery. Do you plan to allow concentrate tonnages and grades to be reported?
Yeah, we're working on this as one of the key features that we're working on currently for the upcoming Mindshed 2027 release. So usually we'll release, say, 2027 at the end of the year, at least in beta form that everyone can see.
Okay. So you mentioned that as being one key part of the update. What are some of the other focus areas for MindSCED going forward?
Well, the two main focus areas for coming releases, the next few coming releases, will be number one, reporting, and number two, haulage. Okay, so there's always improvements that can be made to the haulage planning, including um, being able to limit production by the fleet, the fleet. Um, and in terms of reporting, we're thinking of adding, as Hamish mentioned, uh, uh, for the custom reports at least, a preview of how it's going to look like in Excel.
Okay. Great. So just a reminder, if you have a question, by all means, just add it into the question box on the GoTo platform. So shall we, as regulatory scrutiny around tailings storage and processing waste management continues to increase, how are you seeing mine planning teams adapt their workflows to ensure waste forecasting is treated as an integral part of the scheduling process rather than a downstream activity?
But yeah, I mean, planning engineers have been struggling with this for quite a while. It is, in fact, a requirement. In one way or another, mines have to account for the material leaving the processing plant, regardless of where it goes. It may go to a stockpile for ore concentrate. It may go to a waste tailings pond or a waste um, uh, uh, a waste um, stockpile. Um, so, but and we've received many of these requests to be able to handle this, and that's why we worked hard uh, to recently release the current version, which allows exactly for this. So it allows to an accountability of an accounting that is of the material heading to the tailings pond as well as to either ore or waste stockpiles.
Okay, great. Well, it appears we do not have any more questions. Um, so uh, Thank you very much. The questions that were entered will be forwarded to Hamish and Shoei, and Geovia will compile the answers and send them out to registrants at a later date. So thank you very much, everyone, for attending. Thank you, Shoei, and Hamish in absentia. Michelle.
Thank you, Ryan. And thank you, Shoei, and to Hamish for that interesting presentation. I'd like to thank all of our attendees and ask that you please fill out the short survey that pops up on your screen at the close of the webinar. A link to the video recording of this webinar will be emailed to you tomorrow. For more online presentations like this one, visit the CIM calendar of events on CIM.org. We hope to see you at our next CIM Magazine Solutions Exchange webinar. Have a good afternoon. Thank you.
Thank you.